Okay, we're going to relate standard and factored form. And we're going to pretty much go over how these two forms of a quadratic can help us when graphing. Okay? So first of all, this is considered the standard form. Okay? So this is our standard. And our standard form is usually written as ax squared plus bx plus c. Right? So here's our a value, our b value, and our c value. So we have them all. This is our standard form. And to move from standard to factored form, we go through a process of what's called factoring. That's right. What about to move from factored to standard form? It's expanding. Okay, expanding, and you could say simplifying if you will. Okay, there it is. Okay, so essentially the two things we did all last chapter, we started with expanding and simplifying, so we were in factored form, and we were moving to standard form, and then we moved from standard form to factored form. Now the idea is we got to figure out what each of these forms is helpful. What can they do for us when graphing? Which is most efficient at finding what pattern. So, here's a graph. And we're going to take a look at what we have up here. We're going to discover that standard form, which is what we're in right now, is best for finding a Y-intercept. Okay? So the things we need in terms of graphing is we're going to be looking for an X-intercept. We're going to look for a Y-intercept. We're going to look for Y-intercept, X-intercept, or Vertex. And these three things will help most when graphing a parabola. So a Y-intercept is when it crosses the Y, so let's say it's here. We have an X-intercept here, an X-intercept here, which means our vertex would be somewhere down here. So these will help us graph a parabola, or at least a rough sketch of it. Okay? So, what we want to do is figure out which form, standard or factored, will really help us solve these. And what we're going to find is in standard form, the form we're in right now, helps most with the Y-intercept. In fact, the very last number is the Y-intercept. Okay? So the Y-intercept of this value, and the Y-intercept, remember, is when x is equal to 0, y is equal to negative 15. So in standard form, we can already find a point. Oh, I should have chose a better point. Obviously, it's way down there out of the graph. Okay, but that's fine. It's important for us. Our negative 15. And the reason we know that is because we're setting x equal to 0. So if I put 0 in here and 0 in here, okay? So what is 0 squared?
0.
Times 3? Still 0. 0 times 12? So 0 plus negative 15 is... So instead of actually carrying out all that math, we can just look at the very last number in standard form, and we know that the Y-intercept is 0, negative 15. Now the reason we go to factor form is factor form will help us find X-intercepts, and then from there we can get to vertex. Okay? So we're going to factor this, which is everything we were doing last chapter. So we have our g at x is equal to, and I'm going to go a little quicker since I hope we're relatively proficient at this. 3x squared plus 12x minus 15. So I'm going to find the factors of the first and last term. So I got 1 and 3 as one set, and 1, 15, and 3 and 5. The two of them need to add up to positive 12. 3, 9, 5, no. There we go. Okay. So 3 and 1 and 1 and 15. 1 and 15 and 3 and 1 is 3. To be positive 12, I need the 3 to be negative, which means the 1 needed to be a negative value. So when I go to put this in factored form, I have a 3x and a 1x. And the 3x was multiplied by negative 1, so they go in opposite brackets. And the 1 was times 15, so they go in opposite brackets. So this is my factored form right now. Okay? This factor form can help us when finding an X-intercept, because an X-intercept is when the Y value is 0. So I'm going to replace G at X or Y with 0. Okay? In order to get 0, okay, and we could have actually factored out a value of 3 at this point. It would have made things a little easier if I took in a common factor of 3, but it'll still work in this manner. This is a bracket times another bracket. In other words, the two brackets are being multiplied to get 0. You can only multiply by one number to get 0. What is it? 0. So in other words, one of these, if not both, of the brackets have to equal 0, okay, in order to get a Y-intercept. So in order to figure out how to turn a bracket into 0, we have to find values of X that will do this. So we're going to split this equation. We're going to put 0 is equal to 3x plus 15. And 0 is equal to, and that can be just written as x minus 1. And we isolate for x. In this case, we bring the 1 over. X is equal to positive 1. In the other case, we get 3x is equal to negative 15. And when we divide by 3, x is equal to negative 5. So those are our two X-intercepts. So X-intercepts are when y is equal to 0. So for the first one, this is when x is equal to 1 and y is equal to 0. That's one coordinate. And in this one, we have x is equal to negative 5 and y is equal to 0. So our parabola has two X-intercepts, which makes sense. You have the option of having 2, 1, or 0, and this one has 2. So those are two more points on the graph. So let's kind of go back up to our graph a little. Remember, we had a Y-intercept that was at negative 15, so I'll say 11, 12, 13, 14, 15. We'll say that was here, okay? So negative 15 and 0, that was our Y-intercept. Our two X-intercepts, one's at negative 5 and one's at positive 1. Okay, so we have negative 5 and positive 1. Here's another set of information. So, I have two X-intercepts and a Y-intercept. Which way does this parabola open? Up. The first term, the A term, is positive. And standard or factor form can tell you about that. Okay. So because it opens up, we know we have some parabola that does this. Comes down, crosses the Y-intercept, has a vertex, and then comes back up. Now, is the vertex going to be higher or lower than this Y-intercept? Will the vertex be higher or lower than that Y-intercept? Higher? Why higher? A vertex is what? Do you use two words that start with M usually to describe them? Right. Has to do with extremes. A max. Your vertex is either your maximum point or your minimum point. Oh, this showed up. You guys should have told me that. Okay. So, if it's a max or a min, if it's opening upwards, what is it? The vertex, a max or a min? It's a min, technically, right? And if it's opening downwards, it's a max, okay? So, if it's a min, is the vertex below or above the Y-intercept? Has to be below. It's the minimum point. It has to be the lowest point. So, let's try to find our vertex. From here, to find a vertex, we look for something called the axis of symmetry, which is like an imaginary line running through the middle of a graph. Okay, we'll call it the AOS. And the AOS is essentially, they use these letters R plus S divided by 2. The R and S are the X-intercepts. So our X-intercepts are 1 and negative 5. So we take negative 1 and we add, oh, sorry, that's wrong. We take positive 1. Then we add negative 5 and divide it by 2. What is 1 plus negative 5? Negative 4 over 2. Negative 4 divided by 2? Negative 2. So this is the X value of the vertex. It's also the axis of symmetry, which means it's a number, or it's an imaginary line running through the middle of this parabola. Okay, that's directly between the two X-intercepts. So the X value of the vertex is 2. So our vertex, we know the X value is negative 2. The Y value is still unknown to us. to find the y value, we're going to take this x value here, and we're going to plug it back in to either the factored form or the standard form. It doesn't make a difference to find the y coordinate. So this is something we did in chapter 1, and I'll do the standard form just so you can see the g at x here. So we'll plug it back into the standard. And again, you can do either form. We're going to find g at -2. Remember in chapter 1 doing something like this? The original equation read 3x squared, so it's going to be 3 -2 squared plus 12, so plus 12 times x. X is replaced by -2, and it was minus 15? Negative 15. Great. So now we're plugging in -2 to help us find the y coordinate. So we continue this. -2 squared is 4. 4 times 3 is? Not -12. What's negative times a negative? Positive. That's right. So we have positive 12. What's 12 times -2? -24. And then minus 15. This will become -12. So -27. Who wants to check that for me? -27, -27. I think that's right. Great, so it is -27. So our vertex, and I've chosen a really bad graph to represent this because my graph doesn't go that low. But our vertex is at -2 and -27. So our vertex, let's just say we skip a few and this is -27. Here is our vertex. It's at -2 and -27. So if we were to connect these dots, our parabola essentially does this. It's not the best drawn one. But this is what we're looking at. And I'll actually show you on a graphing calculator, if you just give me a second. So here's a much better description of our graph. Okay? Here's it in standard form. We have our two X-intercepts, our Y-intercept, and our vertex. In the next graph I'm going to show you, this one's red. When you look at your notes, it'll be red. Here's the factored form. It's the exact same parabola because the factored and standard form are representing the exact same thing. The X-intercepts are the same, the Y-intercepts the same, the vertex is the same. We just represent it differently. So both of these are equal. They represent the exact same thing. Okay? So let's kind of just quickly take a look at what we did.